Mm-mm-mm. Dancing in the dark. Mm-mm-mm-mm. Do you know this song? I don't have a person, but I'm singing it. Oh my God, this a work of art of a song. Mm-mm-mm. Mm-mm-mm-mm. I'm actually singing this for you because you're about to be trapped by the factions. Uh, I don't know. I just want you guys to be having fun when, watching these lectures. I don't want you guys to be bored or something. So, if you're that kind of a person who have an attitude, well, you're gonna have a tough time when watching these videos, right? Because I don't know. I'm a stupid guy teaching you, and I'll be singing whenever I want. Okay, let's actually start with today's lectures, ladies and gentlemen, and we're continuing with functions. But if you can see the stack of today, well, it's we're gonna have quite of a journey, isn't it? After this lecture, we will actually continue to exponential functions, and then after continuing with exponential functions, we will do perhaps. Now we'll see where we're gonna go from there. Okay, let's actually start answering these questions. They are saying that below are the graphs of f at x that has x squared plus bx minus 3 and g at x that equals to a x plus p, right? As they say, f has a turning point at c. This is c, right? This is c and passes through the x-axis at this point that is actually 1. D is the y-intercept of both f and g. I don't say it. Oh, okay, yeah, it is. Yeah, it is. I can see. So D is the y-intercept of both f and g. Also intersect each other at E and J, right? Okay. 4.1, write down the value of P. They are not saying that we should, they are not saying that we should calculate. They are saying that we need to write the value of P. And this is easy. You know that the value of P is the x asymptote or the the x asymptote of this red function, right? So we can see that the x asymptote is actually passing at what? It actually passing at 1. Can you see? So this means that the value of p is actually 1, negative 1, by the way. Why is it negative 1? Because it's positive here. When we take it back to the equation, it has to be a negative p. So it means that now on our equation of g at x, we are having a x minus 1. That's what we have up to this point. Number 2, calculate the coordinate of C. Okay, no. Show that A is 3 and B is 2, right? So we need to show that this value of A is 3 and B is actually 2. How do we actually do that? Which one is extremely easy to first find? Okay, there's something interesting here that I actually want us to know. You can see that this point D is common on both functions, the black function. Guys, I don't know, but most of you guys may not find this funny, but I find a lot of people, racist people and everything. That's not like. Okay, if you find this offensive, I'm sorry. Okay, by the way, I'm just I'm just a guy who love laughing. That's something I'm going to tell you. I'm just a person who love laughing, right? I laugh at everything. If you come to me, well, I will laugh. So having the black function and the red function on a white sheet. Dark humor, isn't it? Okay, it's fine. So we actually see that the quadratic function and this red function, they all overlap at the point D, right? And then, but what is the coordinates of D? We know that the x coordinate of D is 0 because, as you can see, it is 0. But what is, so the coordinate of D, it is actually giving us the y value of the quadratic expression, right? And the y value of the quadratic expression, we all see that it is actually what? Minus 3, right? So it means that if we say f at x where x is 0. If we put 0 here and we put 0 here, we're going to left with the y-intercept of -3. So it means that here at point D, we're actually having what? -3. How does that help us? It helps us because now we have a point for the red function, because we want to determine the value of what? To determine the value of a. So what do? We know that we're having point D, that is 0 and -3. So what this means is, because this D is also overlapping on this red function at this point, we're saying that when y is -3, we don't know what the value of a is what we're looking for. X is 0, and then we're going to have -1. So we're going to have -3 times the minus of 1, and then we get that a actually equals to what? A actually equals to 3, and it is what they wanted us to show, right? Now let's find the value of b. How do we find the value of b? Well, we are given f at x that equals to -x squared plus bx minus 3, right? So how do we actually find this this value of b? How do we actually do it? Now let's actually go back. We realize that we also have got this point, right? The x-intercept, right? At this point, this is 1, by the way. So to rewrite it, I can actually create this and say we have 1 and 0, right? This is the x-intercept. It is passing it at 1, and the y is 0. So we're gonna say, okay, we have got this point that is the x-intercept that is actually at 1 and 0. We're going to say, okay, when x is 1, y is 0. So y is 0 when x is what? Is 1, right? -3. So 0 is going to be -1 plus b minus 3. So this is going to give us, right? I don't know this, because like here they're actually saying that we need to show that b equals to 2, right? But I'm not finding b equaling to 2. Guys, I've lost my calculator. Okay, I found it. I found b equaling to -4. So no, I actually find b -4, and I actually find b equaling to 4. Let's see what we have done wrong, or let's see what the question has done wrong. What's actually happening here? Something funny is happening, because we know that the x-intercept, it's actually at 1 and 0, right? So we know that when we actually come here, I'm going to say, let me check if I've copied the question correctly. Let me check it. I don't even know where that question is. I truly don't know where that question is. I think I've copied everything correctly. It's x squared plus bx minus 3, and that point is 1, right? Yeah, I've copied everything correctly. So why is it that we don't get b equals to 2 now? Okay, let's actually do this thing all over again, because this is negative. I understand that if we have 1 minus 3, we're gonna get -2. No, this is correct, because like this is negative x squared, right? But what we do is we take this negative outside. We don't put it inside. That's how much I know math. And then we put this one inside, plus 1. Obviously we're gonna have -1 plus b minus 3. I get to b equals to 4. Okay, let me check if b equals to 4. We're gonna still find everything working. Because like when b equals to 4, it means that the function is f at x equals to minus x squared plus 4x minus 3. Let me try to solve for x using the quadratic expression and find if the x-intercept is 1 and it is negative somewhere here. I'm using the quadratic formula, by the way. I might have made a mistake, or I might not have made a mistake. Exactly, like I still, oh my god, now I'm messing it up everything. You see, I still get that the first value of x equals to 1, right? And this is what is in here. This is what is in here, but let's check the value of the other x. It needs to be a negative somewhere here. So let's check if we're gonna get that. No, we get a positive 3. We get a positive 3. It means that this value here is negative 3. So it has actually reflected into a positive 3. It means that this is not correct, right? It means that this is not correct. It means that indeed the examiner is right. B equals to 2. But why is it that we are not getting it? Because we are not getting it. We are incredibly not getting it. What could have went wrong? I don't know, guys. There's something off about this question, because like if you check out the clues, f at x, right? F at x equals to minus x squared plus bx minus 3. It is what I have copied here. Oh my god, I am so stupid. There's no minus in here. There's no minus in here. Oh my god. Wow, I almost flipped out. Like I didn't understand what was going on. Okay, there's no minus here, guys. Let's just redo everything over again. So f at x equals to x squared plus bx minus 3, right? So f at x, you see what we've done? I'm doing everything. It's 1 squared plus b into 1 minus 3. So 0 is 1 plus b minus 3. 0 is minus 2 plus b, and then b actually equals to 2. Yeah. And I don't know, I'm so stupid. If this was a minus, it means that the graph should have changed. It took me time. You see, I'm only human after all. I'm only human after all. Don't put the blame on me. Okay, but that's a good thing, because you also saw that I do make mistakes, and how do I react when I'm on a mistake? Because remember, I don't know the answer. I did not check the memorandum. So now we did find that A equals to 3 and B equals to 2. All right. Now let's go forward. They say, calculate the coordinates of C. What are the coordinates of C? These are the turning point, right? How do we calculate the turning point? X equals to negative B divided by 2a. Negative, what is B? As we see, is 2 divided by 2. What is the value of A? Is 1. So it means that the coordinate, the x coordinates of the turning point is actually at negative 1, right? And then we're going to go back and put negative 1 on the original equation. That is negative 1 squared plus 2 1 minus 3. So what are we going to get? We're going to get negative 1 squared plus 2 1 minus, no. This is negative 1 here. Okay, I get minus 4, right? So they say the coordinates. So the coordinates of C is negative 1 and what? And minus 4. So I come here and say, well, the coordinates is negative 1 and minus 4, right? Now the next question say, write down the range of f. What is the range of f? We now know the range of f, right? The range of f, it is the y values on which the function of f exists. It is f greater than or equals to negative 4, right? Now you know that, right? Determine the equation of the line through C. Okay, determine the equation of the line through C. Determine the equation of the line through C that makes an angle of 45 degrees with the positive x-axis. Those are those questions that a lot of you guys skip. Let's try to figure it out that you don't skip. Determine the equation of the line through C. Where is C? Oh, okay. So this line, it is through C. It means that it passes this value of C, right? That makes an angle of 45 degrees with the positive x-axis. So it is actually making up an angle of 45 degrees in the positive x-axis. So if it is, by the way, this side, this is the negative x-axis. This side, this is the positive x-axis. So it means that this line is not passing here at 0 because 0 is just neutral. It is not negative and it is not positive. But they did specify that it is making an angle of 45 degrees into the, it is making an angle of 45 degrees with the positive x-axis. Okay, guys, look, we haven't done analytical geometry. This is a question that is coming from analytical geometry. I'm not going to dive deep into this because we did not do analytical geometry with you guys. So in analytical geometry, there's this formula that says that the gradient equals to the tan of theta, right? It is coming from analytical geometry. So the gradient, remember the tan, what is the theta that they're giving us? They're giving us that the theta is actually a 45 degrees. When we put 45 degrees in here, we get that the tan of 45 degrees, it's 1, right? So it means that they're telling us the gradient is 1. Now they're saying that it is passing what? It is moving from C to the positive x-axis. What does this recall in you? We have done this. This is a trick question, but now they're tricking you with also trig. This is what is actually happening, ladies and gentlemen. We are having this, it is passing through C, but it is also passing through the center of this axis of symmetry. These asymptotes or whatever, it is passing like this. Why is it passing like this? Why is it passing at C and also at this center? Do you remember what we have done? That if we are having this and then we have this and then we have this, we said there are two lines that is like this and the other line is like this. This is the increasing one and it has a positive gradient. This is the decreasing one and it is a decreasing gradient. And the increasing one has a gradient of m is equals to 1 and the decreasing one has a gradient of m is equals to -1. We did this on the previous videos, right? So at this point you find that because we have found that m equals to 1, so obviously they are talking about this line. So they're actually talking about this line. It was actually a trick question, right? It was actually a trick question. If you don't understand it, go and check the previous line. If you don't understand where this is coming from, we'll do it when we do analytical geometry if you'll be enrolling with us. Thank you very much. Okay, so what are they saying? They are saying that we need to determine this equation, right? So we know that the coordinates of this equation, at least they told us it is passing through C, and we also know that it is passing through this point. So let's try to find y minus y1 equals to mx minus x1. What is y1? Let's use the equation, the coordinates of C, because they are the ones that they told us about here. So y equal minus 4, that will change to positive 4. The m is 1, x minus it will change into plus 1 because this is -1, right? Because of another negative change into 1. So we get that y going to equals to x minus 3. We're going that x is going to equals to y minus 3. Because this one is going to go here and we're going to have 1 minus 4, that is actually minus 3, right? And by the way, what are they actually telling us? If this is y equals to x minus 3, it means that this thing is actually passing through point D. You see, it means that it is actually passing through point D, You see, it is passing through point D because point D is actually 0 and negative 3. So if this is actually, we put 0 here, we're going to have y of negative 3. And this is actually, so it means that it is cutting through point C and point D. All right. And we now realize that, no, this thing is not cutting at 1 on the value of x. It is cutting somewhere at x equals to 3. Because if we say y is 0, we'll get x equals to 3. Okay. Is the straight line determined in 4.5 a tangent to f? Whoa. Is it a tangent? What is a tangent? Tangent touches at least at one point, at most at one point. But this thing is not touching at one point. It is touching at point C. It also touches again at point D. Right? You see? So it is no longer a tangent because it is touching 2 points. The function h at x equals to f m minus x plus q has only one x-intercept at x is equals to 0. Determine the values of m and q. Okay, these are those questions that confuses a lot of people for absolutely no reason. Okay, let's copy this. They are saying we're having h at x, right? That equals to f, and then they say m minus x plus q, and they're saying that x equals to 0, right? What is this? This is, if you check, this is f at x, but this is f at x. But instead of writing x, they've actually replaced it with m minus x. So in other words, on the original equation, wherever there is x, we're gonna put m minus x. So h at x equals to, okay, what is the original function of f at x? F at x is actually x squared plus 2x minus 3, right? So whenever there's x, we're going to put m minus x. So this is what we're going to do. So here is x squared. We're going to put m minus x, and then we'll square it. Minus, we're having minus 2x. So instead of putting x, we're putting what? M minus x. Right, we're having minus 3, we put minus 3, but they also added q, and then we put q, right? So they are saying that x equals to what? X equals to 0, isn't it? They're telling that x equals to 0 at some point. So what do we do about it? It means that we're going to say, okay, they say the function has only one x-intercept, right? They say the function has h at x, f minus and q has only one x-intercept. What do we know about the x-intercept? They say that it has only one x-intercept at x equals to 0. When something has, let's say we're having this function, right? And then it only has got one x-intercept at x equals to 0, right? This is 0 and 0. If this function has only one x-intercept, that is actually at 0, it means that x is 0 and the value of y is 0. That is the coordinates of here, right? Because it is only passing at x equals to 0. So it means that the x coordinates that they're actually giving us, that it is only passing on the x-intercepts. So the x-intercept should be brought by with an y-intercept, and the moment it passes at x equals to 0, it means also the value of y is 0, right? So it means that we know that when x is 0, also y is 0. So I'm going to put 0 on h at x equals to m. Whenever there's x, I'm also going to put 0 squared minus 2 m minus 0 minus 3 plus q, right? So I'm going to have 0 equals to m squared minus 2m minus 3 plus q. Now you are having this wonderful expression. But what does the question say? They say determine the values of m and q. So when you got here, you do something like this. You say, remember, when you on your quadratic expression, you are having x equals to negative b plus or minus b squared minus 4ac divided by 2ac. So at this point, you are not using the quadratic expression, but you use what's inside the quadratic expression. You say that the change equals to b squared minus 4ac. Do you see this? You just say b squared minus 4ac. So here we're going to say this change is going to be 0, and then we're going to be left with b squared minus 4ac. You ask me, Marvel, why are you doing this? This is how it's done. How do you work? I have no idea. It's just working. So these are the procedures of this kind of questions. This is how you actually do them. I don't know what to tell you. Okay, so 0 equals 2. What is b at this point? If you check, this is some sort of a quadratic expression, right? M squared minus 2m. So in another word, a equals to m squared, b equals to minus 2m, c equals to negative 3 plus q, right? So what is the value of b? The value of b is going to be minus 2m, and then you square it, minus 4. What is the value of a? Is going to be m squared, right? What is the value of c? This is the value of c. It is going to be minus 3 plus q, right? So 0 equals to, what is this? This is going to give you 4m squared minus 4m squared times minus 3 plus q, right? Times minus 3 plus q. So what do we do? Let's take the common factor of 4m squared. If we take the common factor of 4m squared, we'll be left with 1 minus 3, plus q, right? So we're gonna divide both sides by what? We divide both sides by 4m squared, divide both sides by 4m squared. You are left with 0, that equals to 1 minus times minus, it will be plus 3 minus q. So you're going to have 0 equals to 4 minus q. So you find that q actually equals to 4. Right? You find that q actually equals to what? Q actually equals to 4. But how do you find the value of m? So you actually come back into the original expression and say, okay, you are having 0 equals to m squared minus 2m minus 3 plus q. So 0 is going to be m squared minus 2m minus 3. But what is q? Is 4. So you're going to say plus 4. So 0 equals to m squared minus 2m. I think this is like plus 1, right? Because minus 3 plus 4 is 1. Yes, exactly. And then you use this equation to find you use the quadratic expression to find the value of m. Most of the time it gives you error, but let's see at this point. Okay, you find that m equals to what? You find that m equals to 1. And again, you should also get another m that equals to 1. Exactly. Even on plus or minus, you get another m that equals to 1. So your value of q is 4 and your value of m is 1. That's actually how you do that. There's something called reflections and whatever. You can identify these values without even calculating by just shifting. Yeah, it is shifting by just shifting the graphs. We're gonna do them. So you don't have to calculate to get these values. You're just going to shift them and get these values. Let's move into the next question. Pam papara pam 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 paparam pam pam. I told you long ago.